Good morning and thank you for joining us. Before we get started, I'd like to go over a few housekeeping items. Please note that all of your lines have been muted to reduce any background noise, and we hope you take full advantage of the question and answer pod on the left side of your screen to ask any questions throughout the presentation. If we are unable to get to your questions, our team will follow up with you offline. This webcast is being recorded and a link will be sent out in a follow-up email for you to view it again or share it with a colleague. On behalf of Contrast Security and Caresoft, I would like to welcome you to today's webcast, Modern Software Assurance Strategies for Government Agencies. Before I introduce today's speaker, I'd like to tell you just a little bit about Caresoft. Caresoft is a government IT solutions provider delivering industry-leading technology products, services, and training to federal, state, local, and education customers on behalf of top-tier manufacturers like Contrast, Red Hat, Adobe, and VMware. Our contact information will be at the end of the presentation, so please don't hesitate to contact us for any of your needs. At this time, I'd like to introduce our speaker for today's webcast, Jeff Williams, co-founder and CTO of Contrast Security. Jeff,
Thanks,
we're all ready when you are.
Fantastic. I'm going to share my screen here and we can just go get started. All right, thank you everyone for joining today. I appreciate it. Today we're going to talk about modern software assurance strategies for government agencies. We're going to talk a lot about DevSecOps. We're going to look at some new technologies called IAST and RASP. And we're going to show in the course of about the next 30, 40 minutes how you can build a modern software assurance program within an agency with modern tools and accelerate software development. Okay, so let's get started. Just a little bit on my background. I've been doing application security or software assurance work for about 25 years. I ran a consulting company called Aspect Security that did tons of work for large government agencies like the Federal Reserve and DOD and World Bank, IMF, and so on. And I also helped to start an organization called OWASP, the Open Web Application Security Project. I was the global chair there for 9 years. And I led some of the major projects there, like the OWASP Top 10 and WebGoat and a number of other tools and standards. And I want you, for the next 40 minutes or so, I want you to forget what you know about the way that you've done application security for the last 15 years or so. It's not working tremendously well, and there's a new alternative way of thinking about the problem. I'm going to call that modern software assurance, as you'll see as we go through the talk. Okay, so look, the rules of the game have changed. I talk to so many companies that tell me, hey, we're not an insurance company, we're not a bank, we're not a government agency, we're really a software company. And more, it's true that successful businesses, successful agencies are software entities. Their business success is based on whether they can build great software and do it fast and secure. So in order to be the best at building software, if you want to be the best agency you can be, then the goal is to take your business processes, take the way that you work and turn it into software fast. The right way to do that these days is to use modern software techniques. That's things like Agile and DevOps. It's moving to microservices and APIs. It's using cloud and containers and tons of libraries. These are sort of the core approaches to building modern software. And that's really the path to being the leader in your category. The problem is most organizations are really struggling to deliver security at the same rate that they're building software. So even today, most organizations can't keep up. They're only securing a small portion of their application portfolio, like the critical applications, or maybe it's the external facing applications. But really, if you want to do application security, you want to do software assurance, you've got to secure all the applications in the portfolio. So how are we going to do that? How are we going to deliver a ton more security without radically changing the cost? This is not a trivial pursuit. This is really important. The harsh reality is that applications are the leading cause of breaches by a wide margin. And it's happened in a bunch of government agencies. It's happening in the private sector as well. More than 2 times the next leading cause of breaches are applications and APIs. That's how the bad guys are getting in. Problems, though, most developers would say that security slows down DevOps. It's an impediment to delivering software fast and feature-full. And you can't just scale up the number of security folks and try to overwhelm the problem with people. There just aren't enough security experts out there. There's roughly 20 million software developers in the world, and a tiny fraction of that is security folks. So we're in this place where we've got these impossible economics. We've got tools and budget to do a little bit of security, and we're producing 10 times the software that we really need to secure. So there's this huge gap that we need to cross. So how are we going to fix the economics of software so that we can actually achieve secured software? Well, at the core of this problem is that DevOps is held back by 15-year-old scan and perimeter-based approach to doing software assurance. The idea is basically, hey, we'll take all our critical software, we'll put a wall around it, we'll scan from the outside like crazy to see if there's any remaining holes, and then that's it. The problem is it just doesn't work. This approach was designed for the pre-cloud era. It doesn't work when you're interconnecting everything. You can't put walls everywhere. And when you've got complex software, you can't just scan it from the outside and expect to find everything. So we need a new approach to this problem. I call today's approach the legacy tool quagmire. There's a ton of different tools in application security. This is just a handful. But you can see there's tools for the IDE, there's manual code review and pen testing, there's software composition analysis tools to analyze open source software. There's static analysis, or SAST. There's dynamic analysis, or DAST. There's fuzzers out there. You might have to deploy a WAF or an NG-WAF or an IPS. In order to do security right today with legacy tools, you're going to need some of all of these. And around each tool, you're going to have to build a team of experts that understand how to use it and can triage false positives and tune it and so on. That's not a recipe for success in a modern software world. So that leaves us with three kind of bleak options. In the first place, you could kill DevOps speed and use all those tools and slow everything down and frankly irritate everybody. Or, and a lot of organizations take this path, you could basically choose compliance. You could run superficial scans that sort of give you a false sense of security but really leave you exposed. Or, and some companies do this too, you can just roll the dice. You put your head in the sand and wait to be breached. None of those are particularly appealing. So the point of my talk today is to tell you about a modern software assurance model. I believe that's what you need if you're going to be a modern software entity. You need to have a security approach that's commensurate with the way that you're building software. So let's look at some of the tools that have been really successful in the market of building modern software. You'll see tools in development like GitHub and JIRA and AppDynamics and New Relic in the performance space, collaboration tools like Slack, and analytics tools like Splunk. These tools are fundamentally different than the tools that have come before. These tools are designed around collaboration. They're designed to integrate with each other. They're designed to make a continuous environment. They foster communication. These tools also run across the entire software development lifecycle. They're not a tool that just sort of happens at one point in time. They're not a strobe light tool. These tools are continuous, running across the entire process. But what's missing is a security tool that looks like these other tools. But really, it isn't out there. Scanners aren't this. The scanners don't have those characteristics. We need a tool that fits in with the other pieces of the modern software platform and allows us to do security as we work on all these other things together. We need that continuous platform for software assurance. So some forward-thinking agencies and companies are embracing a new approach to this problem. Here's some of the things that I've seen. Folks that are using this approach, this modern software assurance approach, they're operating at a massive speed and scale. So one top 5 software company, I've seen them, they secured 1,200 applications in a single year with one dedicated full-time employee to that project. Basically what they did is they enabled developers to do their own security. They gave them the tools and the support that they needed to detect their own vulnerabilities, rewrite code, and check in clean. A Fortune 10 financial services company has cut their pen test budget by 50% because they're using automation to now detect those vulnerabilities. The simple things that we can test for, like cross-site scripting and SQL injection and parameter pollution and XXE and so on. That kind of stuff is automatable. And what we need to do is stop wasting our critical security resources on those things and focus them on the hard, interesting problems like threat modeling and software architecture and so on. A top 3 insurance company has increased their software release velocity by 3 times by using this modern security approach. Basically, they're taking out a lot of the stops and the gates that were stopping their process before, and they're allowing the development teams to prove that they did the right security steps, and once they've done it, then they're enabled to push into production. And lastly, a healthcare company, a top 5 healthcare company, is using protection in production. They're detecting 2.2 million application layer attacks every single month and preventing them from exploiting their applications. This is a level of visibility that other organizations just don't have. So this is really a game-changing approach. Now, how did they do it? They've made the move to what I'll call modern software assurance. So remember, the legacy model is based around firewalling and scanning. It's an outside-in, resource-intensive kind of model. And fundamentally, it introduces a bottleneck. If you have inaccurate tools, like code scanners and vulnerability scanners and firewalls, then you have to have experts involved in the critical path. They have to weed out false positives, they've got to tune the tools, and they've got to do extra work to detect any false negatives. So you're going to need an army of experts. These tools are also not continuous. They run after the fact. And so you get this sort of snapshot, point-in-time results that are instantly out of date. And these tools don't give instant feedback back to the developers, so you get this long feedback loop that might take days or months or years to get feedback back to the developer that needs it so they can fix the problem. Now, the modern approach is quite different. I'm going to call it the embedded model. This is a model where we've put security automation inside the assets that we're trying to protect. I'm talking about software security, so we're going to talk about embedding sensors inside the actual applications that we're trying to test. Now, this approach works at other layers too. You'll see companies that are protecting containers by getting inside the container, like Aqua and other companies. There's folks that are doing this at the operating system level, even companies like Qualys and Tenable. They're doing the same approach. They're putting the security testing inside the thing that's being tested. So when you're testing from within the thing, so within the application, you have much more information. It's a huge information advantage because you have access to not just the HTTP responses, not just the source code. You've got access to everything. You've got the HTTP and the source code, but you've also got access to the control flow and the transactions and the libraries and frameworks and the data flow and all the back-end connections and the configuration of the application. All of that data is available, so you can do much more accurate analysis. That means you can get the experts off the critical path, you can provide real-time feedback, and that allows you to run security continuously throughout the whole process. So it really simplifies the whole approach to application security. And you can use a single platform. You don't need that tool quagmire. you can have a single platform that finds vulnerabilities, analyzes libraries, and protects applications in production. So when we do this, we've got a tool now that becomes part of the foundation for your software and pipeline. These tools work together to allow you to produce software that's not only produced with lots of features at a high speed that customers love, but is also secure and provably secure. So how do we do this? Well, what I'm going to show you today is an approach to DevSecOps. We're going to both shift left, and actually it's really more like expanding left because we're not giving up what we're doing today. And we're going to expand right. So we're going to move into production as well. So we're going to spread security out across the entire process. What I'm going to show you is security in development. And here what we want to do is empower developers. We want them to be able to test their own code and get real-time feedback through the tools they're already using without irritating them, without doing any extra steps. We also want to do security in integration stage, whether it's QA or CI/CD. We want to make sure that we can assure that the code that we're delivering to production is fully secured. We don't want to slow down the builds. We don't want to have extra steps. We don't want to, we want to just use the tools we're already using. But if we do have critical vulnerabilities, this is a good place to create tickets and to break builds and do those sorts of things. And then in operations, we want that protection. We want to know who's attacking, what techniques they're using. We want to prevent those attacks from exploiting any vulnerabilities that we might have, but we don't want to overload the SOC. So I'm going to show you today how we can do these things with contrast. Basically what we're going to do is we're going to start with a typical DevOps pipeline, and we're going to enhance it for DevSecOps. So we're going to use Spring Pet Clinic, which is a Spring application. It's Spring Boot. It's based on Hibernate, and that's pretty typical. We're going to show how we're going to enhance the development environment. We're going to add contrast here to provide instant feedback to the developer so they can fix their code. We're going to add it to our CI/CD environment so that we're getting instant feedback on every commit with every test cycle. And we're going to add it to production so that we can stop attacks, and we're going to see feedback on those attacks immediately in our SIM. So let's get started. I'm going to start with development environment. I've got 3 environments here set up. We're going to look at development. We're going to show how the developer uses this. I've labeled it at the top of the screens because they're going to move around a little bit so you don't get confused. I've also got a CI/CD environment here. We're going to do the same thing here and show how that works here. Then we're going to move to production, and we're going to look at attacks in the production environment. So let's jump in. So I want you to imagine that you're a developer, you're writing some code, and you're maybe writing some development, you're working on some database stuff. So I'm going to refresh this because I've cleared out most of the vulnerabilities out of this for the purposes of this demo. So we've got some database code that we're updating here, and we're going to enable this with contrast so that we can get security feedback. So the first step is to go to the contrast dashboard. Now this is our SaaS environment. There's also a community edition of this. If you're just interested in trying this for yourself, you can go out and do that. This dashboard shows me I've got 24 applications running across 49 different servers. And all of those servers are providing real-time feedback to my dashboard so that I'm always up to date. So there's never a time when you're going to go scan something. Contrast is continuously monitoring all of these applications in parallel. So everything here is up to date. So the first step here is to add the contrast agent to our environment. Now this agent is pretty simple, and for Java, it's just a jar file. For Ruby, it's a gem. For other languages, it's just a library. And all we have to do is add it to our application to get started. I'll show you a Java example, but they're all basically the same. And this works exactly the same way that New Relic or AppDynamics work, by the way, if you're familiar with those performance tools. So I'll download the Java agent here, you can see it's just a few megabytes, and then we'll take that agent and we'll drop it into our environment. So here we've got the contrast agent, and I've done a little bit of this beforehand, but it just takes a second. So I added the contrast.jar here. And now the only thing I need to do is tell this project to use that new sensor. So for this project, we're just going to add it to the Spring Boot plugin. And we're just adding a simple JVM argument to the way we launch this app, pointing to that jar file that we just downloaded. Now look, this is really easy. For .NET, there's a little installer. For other languages, it's just adding a library to the project. But you can add this to any project in a matter of seconds. And then you just run the application normally. That's all the installation. There's no other onboarding. And this application is now going to test itself for vulnerabilities and protect itself against attack and analyze all of its open source libraries for problems. So to use Contrast, all I do is my normal development process. I don't have to change anything about the way I build, test, or deploy my code. Contrast doesn't need access to source code, by the way. It's working entirely off the running application here. So I'm going to just put in some normal testing. I don't have to do anything special here. I just use the application normally, and Contrast is in the background. You'll see some Slack alerts for new vulnerabilities coming up instantly as I do this testing. So we've effectively turned all your QA testing into security testing. So here I'm just clicking on a few simple buttons here just to give you an idea. So Contrast is analyzing the application in the background. It's doing static analysis of all the binary code in the application. It's also analyzing every HTTP request in and out. It's analyzing all the configuration files and all the libraries, all in the background. So now after just a few seconds, when I refresh, I'm using the Contrast Eclipse plugin here, you'll see we've discovered a bunch of new interesting vulnerabilities. We've got some Hibernate injection, stored cross-site scripting, some weak passwords, and some other things. Now, you can look at these vulnerabilities here, or you can go to the Contrast dashboard, and you'll see that Contrast has first built a portfolio of all your applications. So it's helping you keep track of all the code you've got out there. In fact, if you make Contrast part of your standard server build, this happens automatically. All this data will just pour in automatically. And you can see we've built a dashboard for this application itself. You can see here we've got a bunch of libraries, we've exercised most of the app, and we're starting to find some vulnerabilities in dev. We'll come back and do QA in just a second. So let's drill into the vulnerabilities and take a quick look at what we found. So we'll take a look at this Hibernate injection here and see the details. So right away you can see that this is it's a critical vulnerability. Hibernate injection is a lot like SQL injection, just for Hibernate. You see we created a great title. We've got a unique identifier here so you can track it forever. We start a timeline. And no matter how many times this vulnerability gets reported, Contrast will track it all as one thing. So there's no like taking a report from every 6 weeks and trying to link them together. Contrast does all that for you. Contrast also gives you the details of this vulnerability. So here you can see a snippet of the HTTP request. This is the data I entered. I typed Karasoft, and you can see that was accessed in this code, this method, and this line of code, and it ended up in this database query without being properly escaped or parameterized. Now this is the key to injection flaws, is we saw this data flow through the application and land in this query without the proper security. We've effectively proven that this is an exploitable path through the application, and we didn't have to try to exploit it ourselves. This means anyone can do it. Any developer can use this tool and find vulnerabilities, track it to the exact line of code, and make the fix. So Contrast gives you details on exactly what to do to fix this. Here you can see the first approach is to not use that kind of query, but if you have to, then you should use a bind variable, and Contrast gives you the details on that. We also show you the full HTTP request, so you've got a test case, and you can verify that you fixed it correctly. And Contrast gives you all the details, and I think this is kind of cool. This shows the exact line of code where this parameter was read in. It shows you how this query was built over, and there's a number of calls in here that you can drill into if you want. And then it shows where this data actually got sent to the database, and it gives you all the details. Here you can see the details on the query, and then actually the full stack trace from the running application. So this is all really powerful for developers who want to fix this problem. So again, Contrast easily finds a very broad range of vulnerabilities without ever having to run a scan, without having to change anything about the way you build the code. You can see here, I'll just show you the policy quickly. We have a very broad rule set across tons of interesting rules. This is sort of a superset of what a static tool can find and what a dynamic tool can find. Because we analyze the application multiple different ways at once, our rule set is quite broad. And accuracy, again, because we're actually directly measuring the running application, we're not reporting false positives like the other tools do. So there's a bunch there. I want to show you one last feature here. This route coverage feature I think is really cool. What this allows you to do is understand exactly how much of your application has been tested. Now, we just used the application for a minute or two, but you can see Contrast identified 28 routes, and a route is like an exposed endpoint. It's the attack surface of your application. And through using the application, we've used 27 of those routes. But that means that there's still some routes that we haven't touched yet, so we'll dig into that. And you can see which ones are vulnerable. In fact, if you scroll down here, you can see per route, you can see which vulnerabilities are there. But let's imagine we want to see which route hasn't been exercised, so we can go cover it. In this case, it's this route, and if I click on it, Contrast will show you exactly the path to get to that route. So in this case, it's the /manage/loggers. And when I first ran this, I was pretty surprised because I thought I understood this application, but I didn't know that there was a /manage/loggers endpoint that I didn't know about. And this is something that gets woven into the application by Spring Boot automatically and probably unbeknownst to you. So tools like a dynamic scanner will never see this because there's no links to it. And tools like static tools will probably miss this because it's automatically built in by the framework. But Contrast discovers it and lets you know it's there, and so you can then go test it. And it's actually quite powerful. There's a few other pieces to this, like this environment piece that will show you all the environment variables that are involved in launching this. So there's some sensitive information in here that you wouldn't want to disclose. Okay, so that's the vulnerability discovery piece of Contrast. You can also consume these vulnerabilities right within the IDE, and there it's powerful. So for that Hibernate injection, for instance, you can double click into it and bring up the details. All the same details are here, the overview and how to fix it. You can also get the events here, and I like just going to any one of these pieces and clicking on the line of code and going right to the place where I need to make the fix in the code. This is the parameter that would need to be replaced. So look, this is a very powerful way for developers to work. One other thing that Contrast provides here is library analysis. So this is becoming incredibly important. This is the way that Equifax got breached a while back. You need to make sure that your libraries are always up to date. So Contrast does that automatically. It reports all the libraries used in any application continuously across your whole application portfolio. So here I've got a nice database showing me exactly what libraries I have. I can get some nice overview stats here to show me the grades and then how out of date some of my libraries are. And you can get all the details down here, like exactly which version I'm using, like this Tomcat JDBC connector here. I'm using this version. The latest version is this. And you can see I'm actually using this library. Now that's actually really important. Other tools don't tell you how much of the library is actually being used. So that means if there's a vulnerability, you've got to replace it. There's no other option. But here you can see many of these libraries have 0 classes used. They're just a compile time dependency, and they're not actually creating vulnerabilities. So this is an important differentiator for contrast. And for any of these, I can click into it. I'll filter down to just show just the vulnerable ones. And you can click into any of these. Here's this Jackson library that's got a bunch of CVEs associated with it. And I can click in and see exactly the details that I need to know. What CVEs are here, what rating they are, what applications they're part of, and what servers they're running on. So if there's a new vulnerability disclosed tomorrow, Contrast can let you know instantly where that library is. So let's say it's Apache Commons exec. I can quickly search my database. It's always up to date, and I know these are the applications that are using this library and exactly what servers it's running on. And of course, if this was a real vulnerability, Contrast would show it here already. It would tell you that there's a new vulnerability associated with this library. So really powerful capabilities here to help you get a hold of application security. All right, so that's the development environment. Let's switch gears here and move to the CI/CD environment. I'm going to start a test suite here so that you can see as you run your test cases, whether they're in a manual testing environment or they're automated test cases. In fact, every time I commit code and do a build in Jenkins, Contrast will run, or your environment will run all your test cases, and Contrast will be there in the background doing all the security testing essentially for free, no extra steps anywhere. And here you can see, some new vulnerabilities coming up from your environments and reporting them into Contrast. So depending on how this build goes, the Contrast Jenkins plugin can detect it, and if you've exceeded certain threshold number of vulnerabilities, Contrast can fail the build. That's an important way of getting control of security so you don't introduce any new vulnerabilities. Contrast can also open a ticket for you here's a Jenkins integration that's, this is a JIRA integration that's pretty powerful. This is a two-way integration. So if the ticket gets opened automatically, all the developer sees is the ticket, got all the details in it. They can go make this fix, check in the code, close the ticket, and it'll automatically be closed in Contrast. And Contrast will immediately start retesting that issue and alerting you if there's a ongoing violation, if it wasn't fixed correctly. So this is a powerful way of making sure that your software is secure before you deploy it. And everything happens automatically. Now the coolest thing about this is that your development teams are now empowered. They can be in control of whether their software goes into production. You don't need to have a separate security gate blocking deployment. You can just say, if you're clean in Contrast, you don't have any serious vulnerabilities, and you've got good route coverage so that you've tested the whole application, you're approved to go into production with confidence. So that's, I think, very powerful. It'll allow you to accelerate your software development efforts without compromising security. Let's switch to production now. So in the production environment, Contrast works a little differently. Here, Contrast is monitoring applications for attacks. And it's using the exact same instrumentation that it uses to detect vulnerabilities. In fact, an attack is really just an attempt to exploit a vulnerability, right? So they're very related. So it's the same instrumentation that Contrast is now using to detect attacks. But unlike a WAF, which sits in front of the application and doesn't know what it's protecting, Contrast protection is woven into the app itself. So it knows what it's protecting, and it doesn't need training and tuning in order to be able to go into effect and start blocking attacks immediately. Let me show you what I mean. If I go back to the development environment here and look at this, this Hibernate injection that we found, it's in this field. And you can see I can use this page normally, and it reports matches. But if I use an attack here, simple or 1 equals 1 to exploit this vulnerability, now this application reports out all the data in the database. So that's a bad vulnerability. In production, we've just added the contrast agent. We installed it exactly the same way we showed earlier. We just added contrast and made it part of this application. So now, if I go to this same application now running in production, this is actually running in Pivotal Cloud Foundry, and we've got integrations with all the major cloud environments. So if you want to deploy with AWS or Azure or Pivotal or Google or whatever, there's sort of one-click deploy with contrast. Here, if I try to exploit that same vulnerability, you'll see that contrast intervenes and prevents that vulnerability from being exploited. Now, what it actually does under the hood is it throws an exception inside that database call. So basically, it's just like the call to the database failed, but contrast is actually preventing that query from going to the database. Now, this app takes that exception message and puts it on the screen. Most applications will just generate a generic error message, or they'll throw a 500 or whatever. But we're very focused on not disrupting applications, so this just prevents the exploit from happening, allows you to continue working. Now, all that data is going to both the contrast team server, and you can send it directly to your SIEM. So here, we've got our Splunk plugin. This is showing me attacks blocked. You can see most of these attacks were ineffective. An ineffective attack is one that doesn't ever get close to the vulnerability that it's targeting, like a SQL injection attack that never gets anywhere near a SQL query. That's a different kind of thing to deal with. You don't have to do anything to prevent that from exploiting you. This other group, and by the way, WAFs can't do that, right? WAFs don't know whether the attack is heading to a SQL query. The WAF has to block everything. That's why they overblock so much. They break applications, and you need a lot of tuning, a lot of experts to figure out how to make sure the application can work with the WAF. Contrast also blocks attacks. Basically, we're preventing these vulnerabilities from being exploited. So in this case, these are attacks that made it to the vulnerability that they were targeting, and contrast intervened to prevent this attack from succeeding. So you can see here, we've got a ton of attacks on all different applications here. These are some of the different kinds of attacks that we see. Here you can see this CVE is the attack that targeted the struts expression language injection problem that affected Equifax and so many others. We're still seeing widespread use of this attack vector across all of our customers. And if you drill into this, you can see contrast captures a ton of detail around this attack. You can see here it's identified the exact vulnerability. You can see in this case, it detected that it didn't successfully exploit this vulnerability, and you can see the details of this attack trying to exploit the application. Now, effectively, what contrast has done here is we've immunized this application against broad classes of attacks, like SQL injection and expression language injection and cross-site scripting, so that attempts to exploit those vulnerabilities will fail. In effect, for expression language injection, for instance, we've effectively sandboxed the expression language evaluation engines inside the platform, so that when an attacker tries to do something harmful from an expression, like create a file or start a command shell or contact the back-end system, contrast prevents those actions from happening. So we've effectively stopped these attacks multiple ways. What that means is that you get protection not only for known vulnerabilities, like CVEs, but also for unknown vulnerabilities. So all of our customers that use struts and Spring, when the expression language injection vulnerabilities last year came out, all our customers were protected, even before the vulnerability was disclosed, because they had contrast in place that prevents expression language injection and all these other different kinds of attacks. So we can drill into these details. I'll show you, sort of all of them so you can see not just the effective ones, but all the ineffective ones as well. And you can see here's the expression language, here's the SQL injection that we tried a minute ago. Contrast gives you the same level of detail here that it gives you for vulnerabilities. So you can see here's the exact attack, here's where it landed in the SQL query, obviously an attempt to modify the meaning of that SQL query, so Contrast intervened and blocked it. We have the full stack trace, so you can tell the exact line of code that was being targeted by the attacker. You can tell the developers exactly what query was going on. And you can see here, you can see the full HTTP requests. We can even identify the currently logged in user, which is really important. That way, if you want to, you don't have to just block this IP address, forcing the attacker to just move to another IP address. Instead, you can close down the whole account that they were using, maybe force it to be re-authenticated by the account owner. That's much more powerful protection. So, a lot of protection here. In contrast, we have effectively deployed it across this pipeline. You can do it very quickly. In fact, you can automate the deployment of this across large numbers of applications very quickly. Hopefully, we've accomplished our goal. We empowered developers to find and fix their own vulnerabilities. We provide great assurance so that you're confident that what you're pushing into production is secure, and we've optimized it for development teams. And we're providing protection in production, not only against vulnerabilities in your custom code, but also vulnerabilities in all your libraries as well. So we've got quite a lot of protection. This, to me, is the platform for DevSecOps. This allows you to push code into production quickly with security. So I want you to imagine running this at scale. We looked at one app, but now I want you to imagine running it across a portfolio of applications. So we've taken the contrast sensor, and again, we support Java, .NET, Python, Ruby, and Node.js. And you add that to your applications in dev, in QA test environment, your CI/CD environment, and also in production. As you use those apps normally, Contrast is generating a ton of security telemetry about vulnerabilities and attacks. All that telemetry feeds into the Contrast team server, gives you details on custom code vulnerabilities, open source vulnerabilities, as well as attacks and protection in production. But that's really not all of it, right? You take all that data, and it's great to have it in one place, but the important thing is taking that data and making it useful to the people that need it through the tools they're already using. So Contrast, these are some representative integrations. We've got 24 more integrations into all the tools that people use to build software in a modern software development environment. That's really the key, is giving people real-time feedback through the tools they're already using. You could actually run Contrast and get tons and tons of value out of it without ever using our, our dashboard. By the way, everything in the dashboard is API-driven. It's all REST APIs over a mutually authenticated SSL, so you can get data and build dashboards out of the data that we're collecting automatically. So what we want to do is we want to help organizations transition to becoming a modern software assurance organization. And it doesn't happen immediately. What we want to do is get you started with modern software, get it deployed across your enterprise, get it standardized, and then eventually get you to that continuous model where you're in what I call the new normal. And the new normal is where you've eliminated your backlog of vulnerabilities and you're only working on the new vulnerabilities that developers occasionally introduce into applications. When a new one comes up, you fix it right away and you get back to secure. That's a very different approach to application security than anything I've seen from organizations doing security the old way. And it takes about a year if you've got hundreds or thousands of applications. It takes about a year to get to that point where you're in that new normal, but Contrast can get you there and you'll see dramatic results. Every month you'll see your total backlog of vulnerabilities going down by 10, 15%. And by the end of the year, You'll have worked it all off. You'll be in that new normal environment and doing continuous software assurance. This has some big benefits across the organization. At the executive level, you can close that talent gap. You're using your security investment wisely, and you're making measurable improvements to software assurance across your portfolio. The security team, your role is going to change a little bit. You're going to become more coaches and toolsmiths than in the weeds, dealing with day-to-day vulnerabilities. You're going to empower development teams to do their own security. That will let you focus on more strategic activities like threat modeling and security architecture and so on. Development teams, you'll be given a green light. Push your code into production as fast as you want, as long as you made sure that it's secure. That means you've reduced your vulnerabilities and you've got great coverage over the attack surface. And finally, the operations teams can now get that extra visibility at the application layer. Currently, they're mostly blind at that layer, but this will show you exactly who's attacking. You can merge that data in with your network security data and get a real picture of what attackers are trying to do across your whole portfolio without dealing with tons and tons of false alarms. So that's the journey that we can take together. Contrast is here. We're ready to help you. I'd love to take your questions about anything that I've talked about.
Thanks, Jeff. We would like to take the last few minutes to answer some questions. As he said, again, if you would like to submit a question, please look at the Q&A pod in the upper left-hand corner of your console. Now for our first question. Is there a way for Contrast to check all lines of code versus the code that was just exercised?
Yes. So first of all, Contrast does check every line of code statically all the time because it does binary static analysis in the background as it runs. But if you want to check all the code, then you can simply run your set of test cases, right? And you can, if you don't have great test cases, you can use a crawler, you can use Selenium Test Suite, you can even use your manual Q&A process. We even have some folks who that don't have any of that, so they put Contrast Assess in production and let their users exercise the application to give them that coverage over the entire application. We haven't found coverage to be a problem in any organization. They, what we've seen is that folks get tons of coverage just by their normal development process. And I want to change the way you think about security. Don't try to do a complete scan all at once. It's only important to make sure that everything gets tested before it goes into production. So this idea that you need to scan 100% of the application all at once is really not necessary. It's much better to focus on incremental pieces, the piece the developer's working on, making sure that that's clean, and then checking it in clean.
Great. So the next one says, let's say you are developing and including a vulnerable third-party jar and reference it as an import in the code you've been developing. Nothing has been deployed. Does Contrast Agent alert to the vulnerable jar during the development?
Contrast will tell you that the vulnerable jar is there. It will tell you that it's vulnerable, but it will report 0 classes used. If you only import it, nothing ever actually gets invoked, so we can tell that it wasn't actually run. So that you'll see that it'll have 0 classes used, and you won't have to necessarily do anything about it right away.
The next one says, you mentioned Jenkins for doing the secure code gateway and breaking the build. Can you do the same thing with Bamboo?
You can do the same thing with almost any CI/CD tool. We have a nice plugin for Jenkins, but it's super easy to just make a REST call to the Contrast team server and ask it, do I have any open security vulnerabilities? Have I gotten good coverage? If so, then allow the build to continue. Otherwise, fail the build. It's a very simple thing to write, and we're building out more integrations. I think we actually we either do have Bamboo or it's in progress right now already.
Got it. So The next one says, how many programming languages are supported?
Yeah, so we support everything that runs on Java, .NET, Node.js, Ruby, and Python. We're looking at doing more languages. You know, Go and PHP are both kind of at the top of the list, but please let me know if there's languages that you're looking for, and you can help us prioritize what we do next. The goal is to eventually get to all programming languages, and not just web languages and web API languages, but everything.
Okay, so this one says, hi Jeff, do you have any functionality for auto remediation in your platform?
Yeah, so Contrast continuously tests your entire application. So, you know, let's say we discover a vulnerability in an application, and it's there for a few weeks. Some developer fixes it. Contrast will continue to test it, and even if you don't tell Contrast that it's fixed, Contrast will detect that it's no longer seeing that vulnerability, and will close the vulnerability automatically. So then, you know, everything in your system stays up to date, and you know exactly what your security status is across all your apps.
Okay, so the next one says, what are the infrastructure requirements for Contrast?
So using Contrast in a SaaS way is really simple. You create, you know, we'll get you an account on our Contrast SaaS environment, and then you do just exactly what I did. You download the agent, you add it to your application environment. There really are no other infrastructure requirements. Contrast runs perfectly whether you're hosting your application on a laptop or on a physical server, in a VM, in a container, in a cloud, in an elastic environment. We don't really care. So, you know, Contrast runs at the application layer basically as part of the application, so it doesn't much matter. Now, we do support an on-premise deployment, and there the only difference is that you need to stand up an environment to run the Contrast team server, which is pretty straightforward. It's just a, you know, a single server, and just run the installer on it and get going in half an hour.
Okay, so this one says, does Contrast replace the need for Aqua?
No. So Contrast is strictly focused on the application layer. So tools like Aqua and Twistlock operate at the container layer, and they are starting to do some things related to open source libraries, which is a little bit of overlap between us, but generally they're focused on container layer vulnerabilities. So you still need tools to do that. Contrast focuses on the application layer, which is a very different kind of problem. And so, you know, when I think about it, I think the right approach going forward is what I would call the modern software stack. And basically it has instrumentation-based security at each layer. So at the OS layer, it would be something like Carbon Black, or your cloud provider might provide something. At the container layer, it's something like Aqua or Twistlock. At the application layer, it's Contrast. And I do want to point out that Contrast does a really good job on APIs, where static and dynamic tools really struggle, because APIs are just so much more complicated, both from an external-facing perspective for DAS, as well as from a framework perspective for static. Contrast doesn't care. We're inside the API. To us, it just looks like kind of a different kind of HTTP request, and we handle it normally.
Okay, it looks like the last one we have for now is there support for Ruby on Rails?
Yes. So we have Ruby support. It works exactly the same way that I just showed. You add the Ruby agent, Ruby gem to your environment, run your application as normal, and you get both assess and libraries and protect all as part of that. So yeah, absolutely full support.
Okay, so it looks like that is all the time we have for questions at this time. If you have any other questions, we can follow up with you offline. Thanks again, Jeff, for your participation. I want to thank all the participants for joining us today. We hope that you found this webcast informative and helpful to you and your organization. Also, if you would like to take a moment to answer the polling questions on the screen, we would greatly appreciate your feedback for today's webcast. If you're interested in learning more, you can look to the left side of your screen. We've provided a few additional resources that you may use to learn more about Contrast and continuous application security. You can access these resources by clicking on the images. If you have any further questions or would like to request more information, please feel free to contact us. Our contact info is being displayed at the bottom of your screen, so please don't hesitate to call or email. And finally, in the next day or two, we will be emailing you all a link to an archived version of this webcast so you can review it or pass it on to a colleague. Thank you again for attending.